What is AI? Artificial intelligence, AI, refers to the simulation of human intelligence in machines that are programmed to think and learn. These machines can perform tasks that typically require human intelligence, such as visual perception, speech recognition, decision making, and language translation. Branches of AI and their use cases. 1. Machine learning, ML, supervised learning. The model is trained on labeled data. Use cases: spam detection in emails, predicting house prices, image classification. Unsupervised learning. The model is trained on unlabeled data to find hidden patterns. Use cases: customer segmentation and marketing, anomaly detection in network security, pattern recognition in data. Reinforcement learning. The model learns by interacting with the environment and receiving rewards or penalties. Use cases: training autonomous agents for games, e.g., AlphaGo, robotics, e.g., robotic arms, self-driving cars. 2. Deep learning, a subset of machine learning involving neural networks with many layers. It's particularly effective in tasks like image and speech recognition. Use cases: image recognition, identifying objects and people in photos, e.g., Google Photos. Speech recognition, converting spoken language into text, Siri, Alexa. Natural language processing, generating human-like text, e.g., chatbots. Language translation, e.g., Google Translate, and sentiment analysis. 3. Natural language processing, NLP, enables machines to understand and respond to human language. Use cases: chatbots, providing customer support, e.g., banking chatbots. Text summarization, condensing large documents into summaries, e.g., news aggregators. Language translation, translating text between languages, e.g., Duolingo. 4. Computer vision, allows machines to interpret and make decisions based on visual data from the world. Use cases: facial recognition, security and authentication, e.g., Face ID on iPhones. Autonomous vehicles, enabling self-driving cars to perceive their surroundings, e.g., Tesla's autopilot. Medical imaging, assisting in diagnosing diseases from X-rays and MRIs, e.g., detecting tumors. 5. Robotics, involves designing and programming robots to perform tasks. Use cases: manufacturing, automated assembly lines, e.g., car manufacturing. Healthcare, surgical robots, e.g., Da Vinci Surgical System. Service robots, robots that can perform household tasks or assist it in retail environments, e.g., Roomba Pepper Robot. 6. Expert systems, AI systems that mimic the decision-making abilities of a human expert. Use cases: medical diagnosis, systems that provide diagnostic recommendations, e.g., IBM Watson Health. Financial services, automated financial advice and fraud detection systems. Customer support, decision-making systems for resolving customer issues. 7. Fuzzy logic, a form of logic that deals with reasoning that is approximate rather than fixed and exact. Use cases: control systems, HVAC systems that adjust settings based on ambiguous inputs, e.g., fuzzy logic thermostats. Consumer electronics, washing machines that adjust wash cycles based on load size and dirtiness. Automotive, anti-lock braking systems that adapt to varying road conditions. Current developments in AI: 1. Healthcare. AI is being used to develop new drugs, personalized treatments, and improve diagnostic accuracy. 2. Autonomous vehicles. Self-driving cars use AI to navigate and make real-time decisions on the road. Finance. AI is used for fraud detection, automated trading, and personalized financial advice. 4. Customer service. AI-powered chatbots and virtual assistants provide 24/7 customer support. 5. Natural language processing. Advanced NLP models like GPT-4, which powers this conversation, can generate human-like text, translate languages, and more. 6. Smart homes. AI powers smart home devices that learn user preferences and automate tasks like lighting, heating, and security. Associated concepts and use cases. 1. Neural networks. Inspired by the human brain, these are networks of interconnected nodes, neurons, that process data in layers. Use cases: handwriting recognition, recognizing handwritten text for digitization, e.g., postal address recognition. Image generation, creating realistic images from text descriptions, e.g., DALL-E. Predictive maintenance, predicting equipment failures before they occur in manufacturing. 2. Big data, large volumes of data that AI systems use to learn and make decisions. Big data technologies are essential for training powerful AI models. Use cases: retail, Personalized recommendations and dynamic pricing strategies, e.g., Amazon. Healthcare, analyzing patient data to improve treatment plans and predict disease outbreaks. Finance, risk assessment and credit scoring based on large data sets. 3. Algorithms, step by step procedures or formulas for solving problems. In AI, algorithms are used to process data and make predictions. Use cases: search engines, ranking web pages based on relevance, e.g., Google search. Recommendation systems, suggesting products or content to users, e.g., Netflix, Spotify. Optimization, solving complex logistical problems such as route planning for delivery services, e.g., UPS. 4. Training data, the data used to teach an AI model. The quality and quantity of training data significantly affect the model's performance. Use cases: self-driving cars, training models with millions of miles of driving data to improve safety and performance. Voice assistants, training speech recognition models with diverse accents and languages. Fraud detection, using historical transaction data to train models to identify fraudulent activities. 5. Bias and fairness. Ensuring AI systems make fair decisions without being biased by the data they were trained on is a crucial aspect of AI development. Use cases: hiring processes. Ensuring AI systems used in recruitment do not discriminate based on gender, race, or other biases. Loan approval. Developing fair algorithms to prevent discrimination in financial services. Criminal justice, using AI to ensure fair decision making in legal sentencing and parole decisions. 6. Ethics. The ethical implications of AI, including privacy, job displacement, and decision making transparency, are important considerations. Use cases: privacy, protecting user data in AI applications and ensuring data is used ethically. Job displacement, addressing the impact of AI automation on employment and retraining workers. Transparency, making AI decision-making processes understandable and accountable to users. AI is rapidly evolving with continuous advancements in technology and applications. Understanding these basics provides a foundation to explore more complex and specialized areas of AI.